welcome back. Day 2, here we go. Using the distributive property. So simplify root 3 times root 6 plus 7. We're going to have to distribute this in. Now we actually did multiplication of radicals in the first section, 11:1. So when you multiply a radical with a radical, you just multiply the numbers inside with the other numbers inside. If there were numbers outside, you would multiply those as well. So 3 times 6 is 18. So root 3 times root 6 would be root 18. When you're doing a radical times a regular number, just like if it was x times 7, you would just mush them together and make it 7x. Same thing here. Root 3 times 7 would be 7 root 3. You don't multiply the 7 and the 3 together because one's in a radical, one is not. Then check for perfect squares. 3 doesn't have anything, so 7 root 3 is done for now. But 18 is 9 times 2. Square root of 9 is 3. So we have 3 root 2 plus 7 root 3. They have different numbers in the radical. So I know I see a 3 over there, but we're concerned about the numbers in the radical. We have a root 2 and a root 3. We can't combine those anymore, so that would be our final answer. I know it seems odd probably at first, but we'll be all right. All right, root 5 times 2 would be 2 root 5. Root 5 times root 10, they're both in the radicals, so we can multiply them. 5 times 10 is 50, so root 50. Now 50 has a perfect square. It's 25 times 2. Square root of 25 is 5. So we're left with 2 root 5 plus 5 root 2. Now while those are very similar to each other, they have different numbers in the radical, so we cannot add or subtract them. They have to be the same numbers in the radical. All right, root 2x. Root 2x times root 6x. They're both in the radical. 2 times 6 is 12. X times x is x squared. Root 2x times negative 11. The 11 is not in a radical, so just mush them. Negative 11 root 2x. Now 12x squared has some serious perfect squareage. 12 is 4 times 3. The x squared is perfect, just like you. Square root of 4x squared would be 2x. So we have 2x root 3 minus 11 root 2x. Do they have the exact same thing in the radicals? No. So this is our final answer. Last one. Root 5a times root 5a. Now you can get root 25a squared, but remember my smiley face trick. Square root of smiley face times the square root of smiley face is just regular smiley face. So root 5a times root 5a would be regular 5a. But again, if you want to multiply, get 25a squared and then square root it, fine. I don't care. I don't care. Does it look like I care? I don't. Root 5a times 3, that's a regular number with a radical, so just mush them. 3 root 5a. There are no perfect squares left in 5a, so we're all done. That's good timing.